Okay, welcome to CS 102, Java Programming Language at Rutgers University. These lectures cover chapter 13 of our course textbook, which is Java Collections. So in these lectures, we're going to discuss about the Stack Java Collections. Our main objective is to go through the concept of stacks, the definition, and also the theory behind it. Also, we can use Stack to solve problems. So we shall go through some of the problems we can use Stack to solve. And also we are going to implement Stack using arrays. We can also implement Stack using linked list. So linked list normally we say is a dynamic implementation. And arrays is a static implementation because the size cannot be changed. It's a fixed size. So a stack, again, is a list of homogeneous elements. Addition and also deletion of elements occur only at one end, called the top of the stack. So this means to remove an item from a stack or to place an item into a stack, it only happens at one end of the stack, which we normally call the top of the stack. And also computers use stack to implement method calls. Computers also can use a stack to check if arithmetic expression is correct or wrong. Also, stacks are used to convert recursive algorithms into non-recursive algorithms. So these are some of the examples of a stack. We have a stack of coins. Also, we have stack of trains. We also have a stack of boxes and a stack of books. Also, stack data structure is called the last in, first out, which is the LIFO, or last input, first output, which means, for example, if I want to take a Java programming textbook, I need to take the applied mathematics first, then the word history before I can take Java programming. And applied mathematics was the last item that was placed in the stack. So the last item in will be the first item that comes out. So here we say stacks are also called the last input, the first output, LIFO data structure. In our next lectures, we're going to discuss about queue data structure, which is first in, first out. Because in queue, we have a different end for removing an item and different end for, again, inserting an item or putting an item in the queue. So these are the operations that we can perform on stack. We can push an item, which means adding an element to the stack. We can also pop, which means removing an element from the stack. We can also pick. Pick means we want to see what is on top of the stack, the data that is on top of the stack, but we are not going to remove it. So this example of a stack operation. First, we have an empty stack. We push box A. So right now the stack consists of only one box A. Next, we push box B. So we can see box B is on top of the stack. Now, if I want to remove box A, I will need to remove box B first before I can remove box A. Next, we push box C. So now C is on top of the stack. And then next we pick at the top of elements. So that will return C for us, but we are not going to remove it. We just want to know the data on top of the stack, which is C. Next we push box D. So we have 4 boxes now. The top is D. Now when we pop a stack, D will be removed first because it's the last item that was placed in the stack. So here we pop a stack, D is gone. Now we have C as the top of the stack. So this will be our stack interface class. Again, the first row, we have the class name, which is called StackADT. And normally interface class, we don't need the instant variables, and also we don't need to implement the methods. So the second row normally in the class diagram is supposed to be the variables or the data members. So we leave that as a blank. Then next we have the method to initialize a stack. check if a stack is empty. So this method will return a Boolean type. Return it true means the stack is empty. Return it false means the stack is not empty. We also have a method is full stack. This will check if a stack is full or there's a space. If there's a space, it will return false. If there's no space, it will return true. Then we have the method to push an item into a stack. It's not a returning type, void. Then we have the pick. Pick will return the data type. So here T represents the generic data type. So it can be int, it can be float, character, etc. And then we have the pop method. This method will return or will remove an item from the stack. So it will return the item on top of the stack, remove it. So next, before we implement, again, this is again array implementation. So first we go through the StackException class. So for example, since it's an array, the stack size is fixed. So before we add an element to a stack, we need to check if the stack have a space, whether it's full or not. Also, if we want to remove an item from a stack, we have to check if the stack is empty. Removing an item from an empty stack will give us, again, an exception of underflow, the underflow exception. And overflow exception means when we're trying to put an item into a stack when there's no space. Again, this is a re-implementation. So these are the classes that handle the exceptions, the stack overflow exception and stack underflow exception. We call this the runtime exception. Again, comes with the Java library file. So first we extend or inherit stack exception, inherit from runtime exception. Then now we can have our stack overflow exception extend to the stack exception, and stack underflow exception will be extend. Extend means again inheriting. And so in this case, the parent class is the runtime exception, which again comes with the Java library file. So next we're going to implement the stack using an array. So here we said array implementing a stack is an array of reference variables. So each element of a stack can be assigned to an array slot, which we normally call the index of the array. So normally the top of the stack is the index of the last element added to the stack. Now to keep track of the top position, we are going to use the variable names stack top. So for example, if we assign stack top to 0, it means there's no element in the stack. Now, if the stack top is 5, it means we have a 5th element, 5 elements in the stack. So the stack top variable will keep track of the items. So this is our full stack class. So we have the class name as a stack class. We have our 3 data members. Again, this is a re-implementation. So the mass stack size will be the size of the stack there, in this case, the array size. Stack top, as we said, will be a special variable that will keep track of the top of the stack, position, and also the size of the stack, which is the number of elements in the stack. Here we name our array as a list, and the data type is T, which is a generic type. Now the negative here means all these variables and also the array is private. So private, we had a minus. Plus here means all the methods are public. So first we have the stack class. This will be our default constructor. Then we have another stack class, which is again a constructor with a parameter. Then we have our initialize stack method. Initialize stack method, it works like constructor, but a constructor normally is used when we create a new object. So if we create a stack class object, and the default constructor will be called, or we can specify the size of the stack by using the stack class with parameter. Now, initialize stack means if I have a stack object and I use it a couple of times and there's a data in, if I want to delete all the data, then I will use the initialize stack method to initialize the stack to empty stage. Also, we have the is empty stack, which will check if the stack is empty. Is full stack, we check if the stack is full. Then the push method will make it possible for us to push an item into a stack. We also have the pick method to know what is on top of the stack, and then the pop method to remove an item from the stack. So this example of array implementation, here we have the array size to be 100. So the index is from 0 to 99. In this stack, we have 4 items because we can see the stack top is 4. So we have 4 items. And the array size, the mass stack size is 100. So that's why index from 0 to 99. So that's the concept of a data structure or the Java collections. Again, we have linear and non-linear. And again, our chapter 13, we're going to discuss some of the linears and the non-linear. In our textbook, they go through what is the stack, linked list, and also queue. Non-linear, our textbook discuss the graph and also trees, and we shall go through each one. So our next lectures will be the queue. So we can say linear is basically in order sequentially, and then non-linear, this would be an example of a tree. So that's the example. We have a stack, in and out is on the top, queue in from the rear out will be in the front. And we also have the trees, non-linear, and also graph. Again, we shall know, our textbook didn't cover map. We have set a map data structure. That will be discussed maybe in the future data structure and algorithm course. So this is our stack conceptual view. As we said, we insert an item from the top and we remove an item also from the top. And these are the stack operations as we saw previously. Push means we had an item to the top of the stack. Pop means we remove an item from the top of the stack. Pick means we want to examine the element at the top of the stack. It's empty, we want to determine if there's a space in the stack or if the stack is empty. Actually, it's full is to check if there's a space in the stack. It's empty, we are checking the stack is empty. The size will determine how many elements in the stack. Normal, as we said, we can have a special variable stack top, and that will keep track of the elements in the stack. So anytime we push an item into a stack, we are going to increment the stack top. Anytime we remove an item from the stack, we are going to decrement the stack top. So the stack top surely will tell us the number of quantities in the stack. So now we will start the implementation. Again, this implementation of a stack, we are using array. So first we start with the default constructor, public stack class. Why stack class? Because the constructor name is the same as the class name, so stack class. By default, we say the maximum size for the array will be 100. And the stack top will be 0, so there's no any element in the stack. Then we also create our array name list. The type is T, and the size again is the 100. Mass stack size is 100. So anytime we call the default constructor to create our stack, automatically the size will be 100. Then we also have the method to initialize the stack. To initialize the stack means we use this stack for some time. We may have an element inside or not, but we want to be sure that there's no element. So what we do, we use the for loop to go through all the items in the stack from 0 to 1 less than. So the index, if the stack top is 100, the index will go from 0 to 99. Then each index from 0 to the less than the stack top, we assign null to each element or each index location that way. After we finish, we set the stack top to 0. So this code means we are deleting all the items in the stack. The index start from 0 to less 1, the size. So if the size is 20, it will go from 0 to 19. And each index, we assign node to it, and we set the stack top to 0, make sure it's empty. Next method is to check if the stack is empty. So if a stack is empty, means the stack top should be 0. So here we say, okay, if stack top equal to 0, then we return true to Boolean. The type of the method is Boolean returning type. Now, if it's false, it's empty, stack will return false if this condition is false. Same thing applied to its full stack. If we reach the max stack size, which is 100, then that means there's no space. So if the stack top equal to max stack size, if it's true, then we return true and there's no space. If it's false, means there's a space. The next is to push an item into a stack. Now, if we want to push an item into a stack, this is a re-implementation. We need to check if there's a space in the stack or the array size. So here we say if it's full stack. So if this is true, then we are going to throw the stack overflow exception. If this is false, then we are going to skip and then go to the next line. So 2 steps. We are going to assign the new item to the stack top, and then we increment the stack top. So again, first we check if there's a space. So we say if it's full stack. If it's true, then we throw an exception for stack overflow exception. If it's false, then we come and assign the new item to the stack top, which means we push it in. Then if we assign the new item to the stack top, we need to increment the stack top by 1. Now to check if what is on top of the stack, which is peak, we also have to be concerned with the stack underflow, because if the stack is empty, we cannot check what is on top. So first we check if the stack is empty. If it's empty, then we throw stack underflow exception. If it's false, then we are going to return the top of the stack. So remember, the index is less than 1, the size. So if it's 20, to go from 0 to 19. So here we return list stack top minus 1, which will be on top, the item on top of the stack. Now the pop means we want to remove an item from a stack. This is again a re-implementation. So the first thing we do, we check if there's a space. There's something in the stack, excuse me. We check if the stack is empty. If the stack is empty, then we cannot remove an item from empty stack. We are going to have a stack underflow exception, so we throw it. If its empty stack is false, it means we have an item in the stack. So we are going to decrement the stack top. So if the stack top is 5, we bring it to 4. Then we assign null to the stack top and we delete the item. So that again, Java, as we said earlier, Java comes with a stack class, a built-in stack class. In order to use the Java stack class, we have to import the Java utility package, which we use a lot. For example, when we want to get an input from the keyboard, we use the scanner class. In order to use the scanner class, you have to import the Java utility package. So same thing if you want to use the stack class, the built-in that comes with Java, then we import the Java utility package. And also it consists of all these methods. We have the constructor, default constructor stack. Now, if we are using the built-in stack and Java stack class, the names here must be exactly the same. So the name of, now if I'm creating my own stack class, I can give it any name. But here the name must be stack. We have a method empty that checks if the stack is empty. We also have a method pick that will return the item on top of the stack. It will tell us what is on top, but it's not going to be removed. We have the pop method to remove, and also we throw the empty stack exception. Remember, we say stack underflow. That's the name we gave it because we implement it. But if you are using the class stack for Java built-in utility package, then you have to use the empty stack exception. We also have a push method to push an item to a stack. And we also have a search method to search for an item in the stack. So this search method will return the relative position of the item specified by the object from the top of the stack. So if the item is not in the stack, then I need to return -1. So even if I'm searching an item in the stack, I have to go through the items from the top till I reach it. So that will be the conclusion of these lectures. Again, these lectures will cover the concept of stack, Java built-in stack, and also how we can implement it ourselves. So again, see you in the next lectures, which will be the Q Java collection.